Good morning, respected sir. My name is Heath Pathak and I am currently studying in CSPITC second year. My ID number is 20ce113. For today's MCO presentation, my topic is microprogrammed control. So let's begin. First of all, what is control unit implementation? Implementation of control unit is done in two ways. First is hardwired and second is microprogrammed. In hardwired, memory is given in instruction code which is connected to combinational logic circuit which is externally connected to sequence counter, and then control signals are given. In microprogrammed, first instruction code, then next address generator, then comes the CAR which is control address register, then comes control memory, and then CDR which is control data register. Finally comes the decoding unit which is connected to the control signals. What are control signals? It is a group of bits used to select paths in multiple multiplexers, decoders, arithmetic logic units. Control variables are binary variables which specify micro operations. Certain micro operations are initiated while others rest idle. Control word. It is a string of ones and zeros. Basically, it is a binary string which represents control variables. Control memory. It is a memory that contains control words. Micro instructions. These are control words stored in control memory. Micro instructions specify control signals for execution of micro operations. Microprogram. It is a sequence of micro instructions. Control memory, which is basically ROM. It is called read-only memory. Content of word in ROM at given address specifies micro instructions. Each computer instructions initiates series of micro instructions, which are called microprogram in control memory. These instructions generate micro operations to do the following tasks. First, fetch instruction from main memory. Second, evaluate effective address. Third, execute operation specified by instruction. And fourth, return control to fetch phase for next instruction. Here, in the diagram, it is shown visually. Then comes the external input, which is connected to the next address generator, then CAR, then control memory, which is ROM, then CDR, and then control word. Control memory. This contains micro operations. The micro instruction contains bits that initiate micro operations. Bits determine address of next micro instruction. Control address register specify address of next micro instruction. Next address generator, which is a microprogram sequencer, determines address sequence for control memory. Microprogram sequencer functions. Firstly, it increments CAR by 1, then transfer external address into CAR, and finally, in the third step, it loads initial address into CAR to start control operations. CDR, which is also called control data register or pipeline register, holds micro instruction read from control memory. CDR allows execution of micro operations specified by control words simultaneously with generation of next micro instruction. Control unit can operate without CDR. Microprogram routines. So what is a routine? Routine is a group of instructions stored in control memory. Each computer instruction has its own microprogram routine to generate micro operations that execute the instruction. Subroutine. sequence of micro instructions used by other routines to accomplish particular task. For example, subroutine to generate effective address of operand for memory reference instruction. Subroutine register (SBR) stores return address during subroutine call. Conditional branching. So basically, branching from one routine to another depends on status bit conditions. Status bits provides parameter info such as first carry out of header, second sign bit of number, and lastly mode bits of instruction. Info in status bits can be tested and actions initiated based on their conditions 1 or 0. Unconditional branch. Fix value of status bit to 1. Mapping of instructions. Each computer instruction has its own microprogram routine stored in a given location of the control memory. Mapping. It is basically transformation from instruction code bits to address in control memory where routine is located. Mapping of instruction. Example 4-bit operation code to 7-bit address. So first of all, OP codes of instruction are given: ADD, AND, LDA, which are respectively 0, 1 and 2 in binary form. Then mapping bits are unknown. Address sequencing. Address sequencing capabilities required in control unit are: first, incrementing CAR, second, unconditional or conditional branch depending on status bit conditions, third, mapping from bits of instruction to address for memory control, and lastly, facility for subroutine call and return. The visual depiction of address sequences is given: instruction code, then mapping logic, then comes the multiplexers, then comes control address register, and then finally row. So a basic microprogram example is given of computer configuration. Here, computer instruction format, that is I, OP code and address. 4 computer instruction which are OP code and description. OP code first of all is 0000, 0001, 0010, 0011. In each of these OP code, the description is as follows. Micro instruction format. So F1, F2, F3, CD, VR, AD, 333227. Here F1, F2, F3 are micro operation fields. CD is condition for branching. BR is branch field. AD is address field. Micro instruction fields. In F1 there are micro operation and then symbols. Basically, similarly it is same for F2 and F3. Here symbolic micro instruction. Sample format is label, micro ops, CD, BR, AD. First of all, label. It can be empty or may specify symbolic address terminated with colon. Micro operations consist of 1, 2 or 3 symbols separated by commas. CD, one of UI as said, which is unconditional branch. It can be indirect address bit, it can be sign of AC, or it can be 0 value in AC. BR, it is one of JMP, call, RET and map. AD, it can be symbolic address, next or empty. Here next is fetch routine. It can read instruction from memory and it decode instruction and update PC. Micro instructions, symbolic microprogram and binary microprogram for fetch routine are given respectively. Symbolic microprogram. Control memory. It is of 128 and 20 bit words. First 64 words are routines for 16 machine instructions. Last 64 words are used for other purpose. For example, fetch routine and other subroutines. Mapping. OP code can be mapped into a specific format. Binary micro operations. The visual design of control unit is given here. Again, the visual design of microprogram sequencer is given. So basically, the ROM is connected with MUX, incrementer, car, and input logic. Input logic for microprogram sequencer